All right, folks, I'm going to walk you through the textbook, Chapter 1. And the purpose is a couple of things. One, I wanted to draw attention to some fundamentals that you sort of expected to know at this point before you get into the class. But you might be a little rusty, admittedly. And they're all pretty much in Chapter 1, but there's a lot of information in that chapter, so I thought it'd be worthwhile to just walk it through for you. And that information is units, conversion of units. I also want to make sure you're up to speed on temperature scales and pressure. Plus, I think I can give you a little bit of overview of what we're going to be doing in this course. So I'm just going to walk you through this book. And one thing you might not know is that this guy right here, this author, Larry McIntyre, he used to be the chair of this department until about a year and a half ago. As you know, for Thursday, there will be a quiz where many of the factors for unit conversion, which are listed on the inside cover of your book, you're expected to commit virtually all of these to memory. But the official items that you're supposed to memorize are on that handout that is posted on T-Square. Most of the time in this course, you'll have open book tests, and so you will have this table available to you if you need it as a backup, but it's much, much preferable. You can just do this stuff on the fly in your head. Now, I will not allow, let me put it this way. If the class doesn't perform well in the initial quiz, I may have throughout the semester, until I'm happy with how well you guys do, have a closed portion of a test to keep reiterating the importance of memorizing these unit conversions. But hopefully that won't be necessary. Flipping through here to the front matter of the book, I thought you'd be kind of interested to know that the author actually thanked me for helping contribute to this book. And there's a couple other Georgia Tech folks in here. Dr. John Timinoff and Dr. Wendy Newstetter are also Georgia Tech. That's kind of cool. Okay, so concept number one that's really important is units. Being able to work with units. And here are the basic physical quantities that are called the fundamental units: length, mass, and time, temperature. There are numerous derived units that are composed of these fundamental units that you also need to be familiar with. And I don't know if they have them in this book, but I'll go over them. Examples would be joule and calorie and BTU. These are units of energy. There's Newton and pound force. These are units of force. You need to be familiar with various densities. We often talk about grams per cubic centimeter, pounds per cubic foot. Those are just some of the derived units that you'll become intimately familiar with as the semester goes on. Unit conversion, very important. And this is really sort of demonstrating what we want to see when you're solving a problem. So let me see if I can add a blank page here to demonstrate. So let's suppose we want to figure out suppose you have 1 liter water, and you want to figure out how many grams are in that liter. So we know there are, so what did you make up this little form here, and you know that there's 1 gram per cubic centimeter, but hopefully you will know that there's 1 cubic centimeter per milliliter, and that there's 1,000 milliliters per liter. And so what you can do is these things cancel out. The cubic centimeter in the denominator, the cubic centimeter in the numerator cancel out. Same thing here and here, and here and here. And so you end up with your answer is going to be have the units of grams, which is, of course, 1,000 grams. Okay, another slightly more complicated example of this would be when we had 26,000 miles circumference of the Earth, and we wanted to know how many inches there were. Well, there's 5,280 feet per mile. And let's suppose we want to know how many centimeters are the circumference of the Earth. So I remember that there's 12 inches per foot and 2.54 centimeters per inch. So then we can see this is going to give us the desired units. And I don't have a calculator on me right now, but we could figure out what that is if we multiply it. This number times that number times that number times that number, and the final answer will be in centimeters. Okay, but it's going to be somewhere around 3 times 10 to the 9th centimeters. So that's, basically what we need you to be able to do is to carry out this process and to remember these conversions or relationships. Things like this: 5,280 feet per mile, 12 inches per foot, 2.54 centimeters per inch. These are what you're going to have to memorize. And this is the process that you're going to need to demonstrate to be able to use these conversion factors to convert from one set of units to another. Okay? But it's not something you want to do unless you need to do it. So you should be comfortable both in American engineering units and the SI unit system. So don't needlessly go between grams to pounds. Stick with the unit system you're given. That's the best way to go. Okay. I think it is useful to remember typical values of things. I have a few typical values that I have required you to memorize for quiz 1, but you want to kind of amass these things as you move along. Typical, especially if you're thinking about med school, and of course you're a biomedical engineer, it's definitely good to know a typical blood pressure. You need to know what atmospheric pressure is on the Earth in terms of multiple unit systems. That's one atmosphere, but it's also 101.3 kilopascals and 14.7 pounds per square inch. So these are all kinds of things you should have at the tip of your fingers. There's some typical lengths here. These are all things that if you haven't sort of memorized some of these things, you can use them to your advantage while you're trying to make estimations and decisions on the fly. It just builds up your overall repertoire of experiences in terms of quantitative numbers, of properties, of things that you're going to be dealing with as an engineer. Now, there is a concept here I think that you should pay close attention to, which is the idea of dimensionless variables. They show up a lot in engineering. You'll get to know them quite well in biotransport. And this particular one is called the Reynolds number. You don't need to know it for this class per se, but it is a way to learn something about the flow, the properties of flow of material through a pipe or a blood vessel. And it's a combination of 4 variables, each of which have units, but when you add them in this combination and multiply or divide them, you're going to end up with a number that has no units. And then this number is called Reynolds number. So just be familiar with that concept. And the concept is it's related to a concept called dimensional homogeneity. Which means that the units on the left-hand side of the equal sign, half the equal units on the right-hand side. And you'll be surprised how often people don't remember that. So keep that in mind. Another important concept is extensive and intensive properties. And here is a list of them, and we will be dealing with many of these. And the basic concept is, if we're talking about a property, it's extensive if you take a larger volume or a smaller volume of whatever it is you're talking about, the extensive property will change and intensive property will not. So for example, if you're talking about the density of air, it doesn't matter if you're taking a cup full of air or a house full of air, it's still going to have the same density. That's an intensive property. Whereas the mass of the air in a cup would be quite different than the mass of air inside a house. Therefore, mass is an extensive property. You can only, and a key point is you can only write conservation equations for extensive properties. And I guarantee you, you or your friend will at some point try to write a balance equation where you're balancing mole or mass fractions. Can't do that. But I'll point that out to you in the Problem Solving Studio when it happens. So that's what I wanted to cover in this little podcast or screencast, is just to introduce you to the concept of units and highlight a few things in Chapter 1 that are important for you to pay attention to. This is already getting a bit long, so I'm going to stop here, and I'll come back and talk about temperature in another short screencast, and then pressure in yet another one. Talk to you later.